We know some of the basic rules. We know what an indefinite integral is. Again, it's a family of functions. So in all of our answers, we're going to have plus c in there. And so we are going to do these problems on this page. And as we do, we are going to hopefully use different colors in a variety of ways. We'll roll the dice before each problem. Black, blue, green, purple, red. Let's go. Number 5. Number 5 is red. We're going to take the antiderivative of each of these terms using the shortcuts that we just learned for a polynomial or something that is antidifferentiable in normal ways. We will add 1 to the exponent, and then we will say, well, something times 4 gives me 1. It must be 1/4. Okay? Then we're going to add 1 to that exponent. Something times 3 gives me 1. It must be 1/3. You hear that noise? That's the sound of the buffer in the hall as they go by. You're going to hear it a lot in this video. There it goes. All right, we're going to add 1 to that exponent. It's a 2. Something times 2 gives me 1. It's a half. There it went again in front of the other door. The derivative of something is 1. Basically, it's like this is x to the 0. So we're going to add 1 to that. It gives me 1. Something times 1 gives me 1. It must be 1. And then don't forget your c. Obviously, we can leave that 1 off. If you took the derivative of each of these terms, it would take you back to that. All right, second problem we will do in, you can't see it, but there it is. It's purple. So we are going to do a little rewrite on this one. Before we go any further, I'll look at that and I'm like, oh, x over 2 and then 1 over x, and a little frustrating, a little confusing. So it's okay, just like when you were taking a derivative and you would do a rewrite. Now that you're taking an antiderivative, do a rewrite. This is 1/2 x to the 1. And then this is x to the negative 1. And that's what we're dealing with. Okay, something crazy is about to happen on the second term. We'll play that game in a minute. In the meantime, let's keep moving. So the antiderivative of 1/2 x, well, I know it's x squared. And something times 2 gives me 1/2. So something doubled gives me 1/2. It must be 1/4. And again, here's another way of thinking of it. Old coefficient divided by my new exponent. So 1/2 divided by 2 would give me 1/4. Okay, and then we're in this strange situation where we're thinking, okay, what do I do when I'm trying to figure out, it's kind of crazy, like if I add 1 to this exponent here, let me use another piece of paper here. If I add 1 to this exponent, I would have x to the 0, and then I would do old coefficient divided by new exponent. Oh my goodness, I just divided by 0. I better discard this quickly. So, can't do that. But, here's what you do know. Let's not discard that yet. Here's what you know, and here's what I know. The derivative of a natural log is going to give me 1 over x. It's a fun thing to know. Bring that knowledge out at parties. As we go through this, we're going to actually be pulling out some old rules for derivatives. And then we're going to say, well, that's fantastic. That means I could work backwards and do the integral of 1 over x and get natural log, which I'm about to do. Let's change it a little bit up, though. Change it up a little bit. You can't take the log of a negative number and still play with real numbers, so we're going to take the absolute value of that x. So here we go. This integral becomes natural log of absolute value of x, and then don't forget your c. All right, third problem is going to be done in black. I suggest a rewrite on this, and that's going to be the integral. Notice it is, again, an indefinite integral. I don't know the numbers here. And that is x to the 1/3, and then dx. So we're going to add 1 to this exponent. So we're really going to have, I'm just going to keep using this as scrap paper as we go. I'm going to have 1/3, and I'm going to add 1 to that, which is really like adding 3/3. That's going to give me 4/3. So my exponent is 4/3. So x to the 4/3. Something times 4/3 gives me 1. So here's another way of looking at it. 1 divided by 4/3. 1 old coefficient, 1 divided by 4/3 is really going to give me 1 times 3/4, which is 3/4. So 3/4 x and then plus c. There we go. Next problem is done in red. Let's do a rewrite on this one as well. Move 5. 5 let's see, this is x to the 1/2, but it's in the denominator, so we'll bring it up and call it negative 1/2. There we go. Now we'll add 1 to that exponent, meaning negative 1/2 plus 1 is positive 1/2. 5 divided by 1/2, it's not 5 divided by 2, it's 5 divided by 1/2. That, my friends, is 10, because it makes sense. 10 times 1/2 gives me 5, and then plus c. I'm okay leaving it like this. I was okay leaving this one like this. If you want to be like, oh, that's really 10 times the square root of x, and then plus c. That's cool. You can. I'm not. All right. The next problem, done and we're not doing it. That's it. We're just not doing it. Next problem, 4dz. If we roll a 6, we don't do it. We have to come back to it at the end. That's a 1. Well, that's black. So here goes. 4dz. Oh, here comes the floor buffer again. This is not dx, or the previous problem that we skipped. We will come back to it. It's not dy. I feel like I have to talk loudly. I don't know how loudly you can hear it, but it's pretty loud. This is not dx or dy, but this is dz, which really means that's the variable we're dealing with. I think in a practical sense, when we're dealing with x, that tells me, we have some graph and we're dealing with the area from that function to the x-axis. We've been through that. If it's dz, it would be against the z-axis. That's kind of three-dimensional. The y-axis would be something maybe a little sideways like that. So, and we don't have to use x, y, z. We can use theta. We can use whatever we want to use because it doesn't have to be something that's represented graphically. Long story short, what's the antiderivative of 4? I said, what's the antiderivative of 4? You can't hear me over the sound of the floor buffer. Anyway, it's a 4. 4 what? The derivative of what will give me 4? Well, you would say 4x, and you would be right, but we're not dealing with x. We're dealing with z. The derivative of 4z is 4. And I know, you're like, well, 4x, why not 4x? Again, there's your z, and that tells you what variable you're dealing with. Okay, next problem is also black. I think these are loaded dice. Oh my. Oh my. What is that? What in the world is that? Oh, I'm panicking. I hope I can remember some really old formulas. I believe I can. The derivative of, this is going to ring a bell. You've seen it before. Arctan is, lovely, isn't it? 1 over 1 plus x squared. While we're at it, if you're looking ahead to the next problem, hopefully I won't roll a 6 and we'd have to skip it. The derivative of arc sine is 1 over square root of 1 minus x squared. You actually already know the answer to these two. Okay, so I'm going to write a somewhat unnecessary, I need to soundproof this thing. I need to write a somewhat unnecessary step that you do not have to write, but it just sort of demonstrates, because if you're looking at this and you're like, 1 over 1 plus x squared, I have a dx, I don't have a 1. You do. Check this out. This is the integral of 1 over 1 plus, x squared, and then dx over here on the side, right? So if the derivative of arctan takes me here, then the integral of this takes me back to arctan, okay? So my final answer is simply arctan x and then plus c. This dx is an operation. It's an operation, but it's also multiplied in a sense. So I am going to basically pull it out of that numerator and set it off to the side. Totally okay to do that. So let's see, what color is the next one? 3. Oh, good, I do get to do it, and 3 is green. So this one is that one. Again, slightly unnecessary step. Please, please, please don't write this every time. You don't even have to write it this time, but it's a demonstration that these two are the same thing, which really helps us understand that this is what we're dealing with, and then that dx along with the integral tells me the operation I'm doing, and that means I have arc sine x and then plus c. Okay, I think we're done with that post-it note. So let's keep rolling. All right, skipping the next one. The integral of e to the x is in purple. The integral of e to the x is, okay, the derivative of what is e to the x? I think it's e to the x. Okay, but you're not done because there could have been a constant. All right. Get ready. It's going to be fun. You're going to love it. 1, black. We haven't had any blue yet, have we? No, we have not. Watch. We're going to come back to these, and I'm just going to keep rolling 6s. You're never going to see them. Like, the video is going to be an hour long, me just rolling 6s. Okay, that looks scary. It looks very scary. So what I'm going to do is grab yet another Post-it note. Lucky you. Get to see all kinds of stuff written randomly. The integral of, no, I'm sorry, not the integral. The derivative of something will give me something. And I'm just pulling out some old derivative rules because we are reversing the derivative rules now. Okay? So I am not taking derivatives, I'm taking antiderivatives, which means, again, integrals, antiderivatives, same thing. Which really means that if I know the derivative rules, I can work backwards. The derivative of, this is a very obscure one, a to the x, some constant a to the x, like perhaps, I don't know, 2 to the x, that's where this is going, is really the natural log of a times a to the x. Okay, to put this in terms that will make it a little more palatable, you may have seen this before, the derivative, you may not have, depending on whether I've shown you in class, the derivative of e to the x, e is a number, a constant like a. This is the natural log of e times e to the x. But the natural log of e is 1, so this is e to the x. It's the same thing, okay? Same thing. So here's the deal. If I took the derivative, I'm looking at this one now, of 2 to the x, I would get natural log of 2 times 2 to the x. Okay, good to know. Fantastic. That's great. Which means taking the derivative moves me this way, taking the antiderivative moves me this way. So this isn't one of those where I'm going to add 1 to the exponent or anything like that, or, oh, I need to rearrange a few things. No, no. This is, I knew a rule, and I'm reversing it. That's what this is. So we'll move that over, and we will do that. 2 to the x plus c, we'll write it in a second. Again, here's the deal. If I took the derivative of this, I'd go here. There could have been a constant. Okay, the next problem, I hope I don't roll a 6 because I really want to do this one. Oh, good, 4, and that's purple. Still haven't gotten a blue one yet. This is a lot like this, so let's just write the same answer and hope it works, okay? 2 to the x, and then plus c. If I took the derivative of 2 to the x, would I get 2 to the x? No, I wouldn't. Of course, the derivative of c goes away. That's kind of the point. So we're going to ignore the c in this conversation. But if I took the derivative of 2 to the x, what would I get? Okay? The derivative of 2 to the x, and we just wrote this on the other Post-it note, but we're going to keep going, is natural log of 2 times 2 to the x. All right? You with me? Yeah, good, 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 good. Okay, so here's the fun part. How can I explain this and it make a lot of sense? I'm gonna go crazy on you on this one. I'm really gonna go crazy. It's just gonna be nuts. Or should I? No, let's not. Yeah, let's do. Don't panic. You just saw this on the previous problem, right? This is the previous problem, not the C's. I'm not forgetting the C's. It's just not relevant to the conversation right now, okay? So don't be like, oh, you forgot a C. Yeah, I'm not forgetting. It's just not relevant to what we're dealing with. So this is this. I had to pause and think of the best way to explain this. The natural log of 2 is a constant. You can factor constants out. If we divide by the natural log of 2, they'll cancel, and then the integral of 2 to the x dx is 2 to the x divided by the natural log of 2. Okay? I'm about to write that on the paper. 2 to the x over the natural log of 2. So the answer I have so far is this. It's wrong. It's that. So here's what's going on. If you need to write all this in that box, you can. I'm not going to. But this guided us to this because we already had that previous answer. Sometimes in math, you go back in time and look at things and figure them out. And that's what we just did. But if I took the derivative of this, which I will do, I'll do that on another Post-it note. Not another Post-it note, no. Yes. If I took the derivative of 2 to the x over the natural log of 2, I could really say, oh, natural log of 2 is a constant. Let's factor it out. So 1 over natural log of 2 is actually what I'm factoring out. So 1 over natural log of 2 times the derivative of that. Okay, I just take the 1 over natural log of 2, factor it, put it in the front. So the derivative of 2 to the x, we've been through this a couple times already. First of all, I still have that, 1 over the natural log of 2. And then I have the derivative of 2 to the x, which is natural log of 2 times 2 to the x. Natural log of 2 in the denominator cancels with the 1 in the numerator, and it leaves me with 2 to the x. So it works. The derivative of this is that. Fun stuff. Okay, what number are we going to roll next? Lost my dice. There they are. Watch, it's going to be a 6. Nope, it's a 3, which is green. Loaded dice, haven't rolled a blue yet. Okay, I recommend, highly recommend on this one, that we do a rewrite. And I'm going to spend a couple steps doing the rewrite. And the rewrite would be x squared over x, 4x over x, and 5 over x. There we go. The x. Good stuff. Let's keep going. Let's reduce a little bit. X squared over x is just x. 4x over x is 4. And 5 over x, and you might say, well, let's bring that x up and it'll be 5 to the negative 1. I hear you, you're not wrong. But here's what I'm also thinking. Remember this one? It was just the natural log. Oh, it's Post-it note time. Don't give me a stack of Post-it notes because then they'll just get wasted, one problem at a time. If the derivative of natural log of x is 1 over x, watch this, then the derivative of 5 natural log of x is 5 over x. So then to go backwards, I would just have 5 natural log of x. So that's exactly what we're going to do. In order to take the derivative of 5 natural log, we'd get 5 over x. The antiderivative of 5 over x is 5 natural log. Ooh, I'm getting ahead of myself. Oh no. We haven't taken the antiderivative yet. Okay, lesson learned. Okay, I was about to be like, let's take an antiderivative. No, we're still doing a rewrite. And so in the process of doing this, I have seen this on so many students' papers in the past. They will be like, oh, well, I'll take the antiderivative of this, and then I'll do a rewrite here, and it's all mixed up, like when have you rewritten, when have you done an antiderivative? We have not yet taken any antiderivatives. We've just done rewrites. This will come in handy in a minute. It's getting ahead of myself. Oh, no. Okay, now we're ready for an antiderivative. Antiderivative of x is x to the 2. Wait, it's 1/2 x to the 2. Could also be written as x squared over 2. All right, 4x. Isn't that what you had? Yep. Lucky you. And then the 5 natural log of absolute value of x, because you can't take the log of a negative number or 0. And then there's kind of one reason why right there, because you'd be dividing by 0 in its derivative. And then plus c. All right, here we go. Let's find the next one. There we go, black. So we are going to do a rewrite, and so that's going to be x over the square root of x plus 3 over the square root of x dx. There's that one. And then I recommend that we subtract some exponents. Okay, we're not going to have this kind of situation with like an x in the denominator and we pull out these kinds of rules. But we are going to have a situation where, let's see, that's x to the 1, that's x to the 1/2. We are subtracting exponents. If you need to write this step in the middle, you may. I find it necessary to write this just for the sake of explanation. 3 over x to the 1/2. There we go. We'll do 1 minus 1/2, and it gives us 1/2. Yes, that's a square root, and it makes sense. The square root of x goes into x, square root of x times. And then 3 over x to the 1/2, you could bring that up, or you could think of it like x to the 0, and then 0 minus 1/2 will still give you negative 1/2 there. Now we've done a rewrite, we're ready for an antiderivative. Let's add 1 to this exponent. That gives us 3/2. And something times 3/2 will give me 1, or 1 divided by 3/2 is, well, 1 divided by 3/2 would just simply be 2/3. It flips it over. And then we'll add 1 to this exponent, which takes it up to positive 1/2. 3 divided by 1/2, not 3 divided by 2, that would be 6. And then plus c. Turn these into radicals if you like. Okay, 2 problems we skipped. We'll come back to them. They're actually relatively easy. And we got the hard ones out of the way. So this problem is 4, which is purple. All right, we're dealing with a y. We did that on this one. So I recommend a little bit of a rewrite, and that will be 1/9 y. I just find it easier that way. Same thing. This is like y over 1. So 1 times y and 9 times 1, but nah. And then minus 6, and then dy. Graphically, this would look like some function that is like up against the y-axis. It would be, you know, some function, whatever, and then da-da-da-da-da-da-da, if this was a definite integral, not against the x-axis, okay? And actually, I drew a curve when this technically is a line. This is like y equals mx plus b, only it's x equals my plus b, sort of. Anyway, we'll deal with some of these things later. Add 1 to the exponent. That would be a 2. 1/9 divided by 2. That is not 9 divided by 2. It's 1/9. Like a half of 1/9, which would be 1/18. Plus. Okay. Oops, not plus. Technically, it's going to be minus. We'll fix that real quick. The derivative of something is negative 6. You might say, ooh, negative 6x. It's actually negative 6y because of that. And then plus c, because we're dealing with the y variable. All right, last problem. Come on, be blue, be blue, be blue. Yes, it's blue. Sorry, I screamed in your ear right there. I'm super excited. Okay, you might be thinking, how am I going to do this? How? Oh, no. Just do a rewrite. Let's multiply this. X times x, then plus 2x minus 2x. They cancel, and then minus 4. We're just basically multiplying binomials. It's old skills. There we go. Simplified it. I just wanted to throw one in there like this because sometimes you just need to simplify before you go any further. Sometimes it's just necessary. So we have 1/3 x cubed. The derivative of this would give me x squared minus 4x and then plus c. All right, I think we're done. I'm scanning my paper, making sure I didn't leave off any c's. I did not. I think we're good to go.